Weather, this is J3. Let me have your latest recon plane VHF report. Over.
Will go. Out.
I've been talking about task force organization. Wish you would add something to help clarify this business of executive agent.
Yes, I'll be glad to. First of all, we are organized along very simple, conventional lines. I believe I have a chart which explains it better. The Joint Chiefs of Staff and the Atomic Energy Commission on this level coordinate on the instructions that are to be issued to the task force commander. The Joint Chiefs of Staff control the operation through the executive agent, the Chief of Staff of the Army. The task force commander has operational control of the Air Force, Navy, Army, and scientific task groups. Now, when we were in the United States, the Atomic Energy Commission maintained a control over the scientific personnel at Los Alamos Scientific Laboratory. However, for the operational phase, the Commission appointed General Clarkson as its special representative. And in this way, he controls the entire operation.
I get the picture, Colonel.
Okay, Stincher, you take this one.
What do you feel are the unusual aspects of your operation?
Well, we like to believe that Ivy is a milestone in atomic development. I believe that in many ways Ivy is another Trinity, the beginning of something, and we hope the beginning of the H-bomb era. You know, it's been exactly this thought that General Clarkson has had in being so insistent that the task force support elements be emphasized. The fact that all of us must support the scientific people who are doing such important work. I would say that this is the keynote of the operation.
Excuse me.
While we're here in joint operations, it's a good time to think for a moment of the work of the military task groups. Take the Army, for example. This support group, commanded by Colonel George E. Burritt, provides a variety of services which make it possible to conduct an atomic test such as Ivy at a proving ground outside the continental limits of the United States. At this point in our story, it's necessary to understand the effort behind the collecting of measurement data. For what good is a test unless we can learn, can profit from the experience? Highly specialized, sometimes costly instruments help scientists bring home this vital data. An outstanding example of such specialization is the use of a helium atmosphere box by the Naval Research Laboratory. The plywood tube, looking like a train of boxcars, runs from the Shot Island across the causeways to a detection station on Bogan, a distance of nearly 2 miles. Inside the box, the helium is contained in 200-foot polyethylene balloons, some 45 balloons being required to fill the plywood tube. The detailed progress of the Mike reaction will be studied by utilizing this device. The measurement starts in the Mike CAD with a collimating shield, a large concrete block designed to stop all radiation which might confuse the issue. The setup is a lot like having peepholes in a fence. DT neutrons from the Mike reaction will pass through holes in the concrete wall and react on iron converters to produce gamma rays. These gammas will then be collimated through the long helium tube or column to the detectors. Helium is being used for a good reason. Gammas traveling through normal air will have a difficult time of it because of the relatively large size of an air molecule. Now, the helium molecule is much smaller, and the gammas will have a relatively free path in which to travel, and hence will be 1,000 times more intense at the detectors. This experiment is one example of the kind of unique instrumentation needed for learning the secrets of weapon behavior. In addition to the diagnostic kind of measurement, many studies are being run on the effects expected from a high-order detonation. These projects are being conducted jointly by the AEC and the Department of Defense. As always, there are many questions to be answered. Classical routine questions and special pertinent questions pertaining to the hydrogen device Mike. For example, what will be the blast pressure on and near the ground? Many instruments, like the Wiaco gauge, will measure overpressures at ground level and from 15-foot towers. What will be the blast effects at low altitudes, say up to 300 feet? Mortar shells will label the air with smoke puffs for photographic study of their action. And what about high altitudes? For this, anti-aircraft guns are being used. The bursting shells from these guns will label the air with smoke up to 26,000 feet for a free air pressure measurement. Not only will the ground and air be measured for pressures, but also the water surrounding 0 point. For instance, what will be the motion of the water waves in the lagoon? To get such data, photography will study the movement of these floating targets. And then, what about the underwater shock wave in deep water and its effect on underwater ordnance and vessels? This interesting pressure versus time measurement will be obtained by reading pressure gauges which have been attached to the mooring cables of can buoys. Then there are the questions concerning the direction and magnitude of the wind accompanying the shock wave and the afterwind which follows it. The story of heat or thermal radiation needs continued study. The ever-interesting history of neutrons will be recorded. What amounts of external neutrons are present? And what is their energy distribution? Because of the expected size of the shot, the fallout problem is being extensively analyzed. There are questions on the size of the particles, when they got there, and how hot they are. Rafts placed out in the lagoon constitute one method of collecting this information. For a more realistic kind of evidence, a B-36 and a B-47 will be in the air to find out the effect of blast and heat on delivery aircraft. These heavily instrumented aircraft should bring back a record which will indicate whether delivery techniques need to be changed for very high-yield weapons. Well, you could go on and on about the experimental projects being run on this operation, but in so doing, you run up against the same old problem. Each project is so specialized that it becomes a study in itself. So we have given but an impression of the 60-odd experimental projects being run on Ivy.
Latest word from the control room is that everything's going according to Hoyle.
Is the hydrogen level holding?
Right, just as calculated.
She's holding. She's holding. Isn't that what you're thinking, Crone? It wasn't too long ago, 50 days to be exact, when you stood on the beach and watched Mike arrive in crates. A thing then dismembered, a sleeping giant, a robot taken apart for the long trip across 4,500 miles of lonely ocean. And then it was home. Here in a building more like a laboratory than a workshop, it would be assembled for the last time. As you looked at the mass of crates and boxes, you couldn't help but wonder, could you, whether there would be time to make order out of this chaos. When you remember back, items moved into place like notations in a diary. Yes, for you, Crone. The days of preparation fly in kaleidoscopic fashion across your mind. Days now in the past. Just as Mike itself will soon be in the past.
3, 2, 1, act. H minus 5 minutes. H minus 5 minutes. The shock wave will not arrive for several minutes after 0 time. Keep firm footing until after the wave passes.
Our latest obtained as a wind sounding
You've been here before, flag plot.
shows distinct.
That's General Clarkson, the task force commander, and General Walk, chief of staff. The scientific deputy, Dr. Graves, you've already met. Captain Paul is deputy for naval operations, and General Wise deputy for the Air Force. As you've gathered, a weather briefing is taking place. I should say another weather briefing. You've probably heard many times before how important the weather picture is in an atomic test operation. Weather can make or break a test shot. That's why you want to know up to the last moment just how you stand with the elements. The problem this time is especially acute because this entire area of the Pacific is subject to radiological fallout. And this area is inhabited by some 20,000 people. Plus, of course, the ships of this task force. That's why the RadSafe officer works hand in glove with the weather officer. Oh, by the way, to help you understand this problem, these weathermen are covering an area larger than the United States with 10 weather aircraft and 11 fixed weather stations. To put it mildly, that's quite a territory to cover. Let's listen in, shall we?
This is a plot of the latest winds received from Inuiatak, showing that in the lower levels to 20,000 feet, we have a typical trade situation, followed by southerlies aloft, by westerlies above that, which extend clear up to 85,000 feet. This is just about as good as we can expect. This picture, in addition to the total weather consideration, indicates that all of the weather factors are favorable for our scheduled event. That's all I have, sir.
Any chance of showers?
Not within the next 48 hours over the entire Marshalls.
How about cloud cover?
A few cumulus move in, but if we go off on schedule, nothing to bother the operation.
Are you satisfied from the radiological standpoint, Commander Maynard?
Yes, sir. The situation is ideal since the entire fallout pattern is to the north of the inhabited islands.
Thank you, Joan.
The time is now H minus 2 minutes.
Okay, I'll check with staff.
Minus 2 minutes.
One quick question, Dr. Graves.
That'd be quick. We haven't much time.
I see. How soon after the shot will you know how big Mike went at?
We will get rough estimates, like from the bang meter, a few minutes after the shot. See you later.
Right.
Why, sir?